All right, today we're going to look at PCBs, which are a chemical that has a lot to do with us in this area. PCBs, also known as polychlorinated biphenyls. So thousands of medical PCB studies have shown that these PCBs cause a wide variety of health effects, often at very low exposure levels in people. The average American already carries enough PCB in his or her body to meet or exceed the minimum threshold for beginning health problems due to PCB, which means that we already have enough of these chemicals in our body that could cause health problems. And good thing for us. So in Northeast Wisconsin, we have a much higher PCB exposures and greater health risks. So if you didn't catch that sarcasm, that's not a good thing for us. It just means that there are more of these PCBs around the area here than normal. So we come into contact with these more often, and we probably interact with them more than most people do, so we have much higher PCB exposures. So what effects can they have on us? The International Agency for Research on Cancer classifies PCBs into group 2A, which means they probably cause cancer. A lot of these things that are cancer-causing agents, carcinogens, we can't obviously test them on people. Like, we can't just give someone a bunch of PCBs and see if it gives them cancer. So a lot of it is based on available studies that have accidental ingestion of large doses. Since we can't just give them to people, we have to find people who have had them. So it suggests an association between cancer and exposure to PCBs. The increased risk of liver cancer emerged consistently in different studies. So liver cancer is a thing that it probably, like they said, but it gives you. So there's a bunch of different types of PCBs, 209 different kinds. They don't all have the same effect. Some have properties like dioxin. So if you think back to Trashed, the video we just watched, so they have properties like one of the most toxic man-made compounds ever. Sweet. So they are very toxic. Some PCBs act like hormones, so messengers within your body, messenger chemicals. And if the wrong signals are sent, the wrong messages are sent in your body, that can really cause some havoc within your body. And then others are literally just nerve poisons. They poison your nervous system. So that communication between your brain and everything else. And again, sweet. Here in the Fox River Valley in the Bay of Green Bay, we've got a mixture of every single one of them. They're all just here. So PCBs can get in the body in 3 different ways. Swallowed in contaminated food and drink. So for us in this area, it's usually animals that and spend a lot of time in the Fox River, as well as potentially drinking right out of there. Like I said, eating some fish that live in that river. We can inhale it as vapor, which we probably in our day-to-day lives don't really have a lot of chance to do, but it happens. And then absorbs through the skin. If you spend a lot of time digging in the silt and mud at the bottom of the Fox River, you could absorb it through your skin. Once it's in your body, it lodges in the fat of your body, and it stays there for a long time. So the reason that we used PCBs is because they were so stable and they helped coat our paper, but that stability also prevents our body from breaking them down. So it was a good thing. Turns out it's really not for us. So where are PCBs usually found in the fish? In the fat, like we just said. So that fat that happens along the back, along the sides of the fish, along the belly. So this is actually a picture that's showing if you were to catch a fish and need to eat it, this is what you would have to remove. So you'd have to take its skin off, all of that fat. So the PCBs are found in that fatty tissue. Here's some of the health risks associated with PCBs. So they alter major systems like our immune system, the hormones, which we already talked about, those messenger chemicals, the nervous system, which is that's your brain, your nerves, your spinal cord, that kind of thing, and your enzyme system, which helps. Your enzymes are things that help your body perform the chemical reactions it needs to survive. So PCBs affect a lot of your body's functions and your organs. And it is, again, associated with an increase in cancer. We talked about that. They've also been correlated with miscarriages, premature births, birth defects, weakened immune systems, increased liver, skin, brain, and breast cancers. They're also linked to heart disease, diabetes, autoimmune disease, liver damage, mood disorders, Parkinson's, reproductive and sexual effects. They also might mess with our hearing, affect the structure of the inner ear, so all those bones in the inner ear that make us be able to hear. Looking ahead into the future, so PCBs have been banned since 1979. And in the Fox Valley, approximately 1/2 of all the PCBs ever used ended up in the river. So some ended up on the paper that we wanted to, because all these PCBs were in the paper mills. Half of them ended up in the river. So huge cleanup efforts are underway to clean up the hot spots. And 300 to 500 pounds moved down the river each year. Here is a video of the things that are happening right now. So we will watch this video, and this is just a couple years old. So what's ever happening in here, actually, we have finished doing right now. So I'm going to play this. For you here. Once it loads, sorry.
Efforts to clean up an environmental problem on the other side of the state are underway again. In April, dredging crews got back to work on the Fox River. For years, Wisconsin paper companies and the government have been locked in a legal battle over the cleanup of cancer-causing PCBs. In Wisconsin reporter Art Hackett discovered even though the lawsuits remain, the cleanup is on track in De Pere.
I've watched the dredging outside my door down here.
Bud Harris lives just up a hill from the Fox River. The dredges are part of the effort to rid the Fox of PCBs. Harris has been watching PCBs for most of his professional career.
Okay, Dick. PCBs, we knew they were there, but the issue was, okay, so what are the real effects?
For a 30-year period beginning around 1954, PCBs were an ingredient a few of the mills used to coat paper. Many other mills recycled scraps of that original paper to make other products. PCBs washed out of the mills, into the water, and settled into the sediment. 10 years ago, while attorneys for paper companies battled over who was responsible for paying the bills, the DNR studied whether it was possible to dredge sediments from the river without making the problem worse. The answer was yes.
The dredging of PCBs from the Fox River has now reached industrial scale. At times, the two dredges have operated at the end of pipelines stretching for 10 miles. What is that brown stuff on the top?
That's the sediment.
Just as the paper machines operated continuously turning fibers into paper, the sediment never stops between the time when the dredge pumps it into the pipeline and the time when it drops into a pile awaiting a truck ride to a landfill.
It's kind of a unique situation because nobody's ever set a process up like this without some kind of buffer between the dredges and the process unit. It's never been done before, and that's something we're very proud of.
The material is pumped into huge presses which force out the water, leaving nearly dry wafers of PCB-contaminated cake. Mangrum says the project will ultimately remove 3.8 million cubic yards of material from the riverbed. In addition, 500 acres of contaminated river bottom will be capped with an isolating layer of sand and crushed rock.
Well, right now, it's scheduled 7 years for dredging, two additional years for capping. Our goal is complete at least a year in advance. We're ahead of schedule now, and we project to stay ahead of schedule.
The decision to cap areas which were too difficult or expensive to dredge was controversial. But environmental scientist Bud Harris says he accepts it as part of the solution.
I was never a proponent that it should only be capping. But one of the things that we knew pretty early on is that even with dredging, you are going to get residual. You'll never get it all. It's not like vacuuming under the rug, you know.
So far, Harris says the cleanup process appears to be working. The U.S. Environmental Protection Agency recently released a review of the first 5 years of the Fox project. This involved Lake Butamore near Menasha. The EPA's measurements showed remaining PCB concentrations of 0.22 parts per million. That is below EPA standards.
If, in fact, they get the sediment concentrations in the river to 0.2, I believe it probably will be protective of most of the wildlife that we're concerned about.
About 8 pounds.
My concern is more in terms of the long-term monitoring. Not only monitoring the security of those caps, I think that's terribly important and need to be monitored. You have to monitor the effectiveness of the whole process.
We certainly don't anticipate major disturbance in the caps.
Jay Groskopf is with Bolt Construction. The Wisconsin DNR has contracted with Bolt to monitor the dredging and the effectiveness of the cleanup.
We're really looking at successive generations of fish and these waterfowl and other things in terms of are the PCBs being eliminated from the parents, in turn not being passed on to the offspring.
The question is, for how long?
There really isn't a defined timetable yet. There's a goal to eliminate the fish advisories and the waterfowl advisories, and we don't know if that's going to take 10 years, 15 years, 30 years, 50 years. I mean, it's a hard thing to present to the public. You know, unknowns are always hard to present to the public.
The cleanup process still has at least 7 years to run, and then there will be a wait for the food chain to clear itself.
The models suggest that there's a half-life of 5 years, so
Bud Harris ran through a calculation of how long it will take to clear microorganisms, then fish, then birds.
you can begin to project that out. So what do you have to get to in the water column to be protective? About 2 parts per trillion. So that's going to be another 4 decades.
2 parts per trillion of a compound which first entered the Fox River in 1954.
By 2054, there shouldn't be fish advisories by that time.
But that's 100 years.
Yes, it's 100 years.
Even though the PCB contamination happened years ago, the current cleanup is expected to prevent the remaining PCBs from entering Lake Michigan. The dredging and capping project is expected to be completed by 2017.
Okay, so they ended up being a little behind schedule, and 2017 isn't when they finished it. They just ended up finishing it last year. So 2 or 3 years behind schedule. Not bad if you think about a giant project like that. But now you see what PCBs were. They were used to coat the paper and everything like that. And they were told at the time, whether this is the truth or not, that they can just dump them in the river as long as they're diluted. And that was not true. So here is just a view at what the cleanup looked like. So here's down Lake Winnebago. Here's our first section here from Little Lake Butamore, so right off Lake Winnebago there, up to Appleton. And then we went from Appleton to Little Rapids to the De Pere Dam, then De Pere Dam to Green Bay, and then the Bay of Green Bay. And these are just the companies that were responsible for it. So we had Georgia Pacific, Sunoco, NCR, Appleton Papers, Riverside Paper, SCA, and PH Glatfelter. Were all these paper mills that were along the river that were just dumping it in and letting it go up. So here is the initial mass of what the PCBs were. So we're starting down in Neenah. And then look at all this in here. And this is going to be from all those 2 paper mills down here. Then we get up to Menasha and Little Lake Butamore. There's a lot. And then we see these little red lines. Those are the dams along the Fox River. So you'll see sometimes it builds up before a dam, and then it's a little clear afterwards, and it builds up before, and it's a little clear afterwards. That's just how the water goes. So this is all like Nina Menasha, and then we get to Appleton, and then to Kimberly. They used to have the mill over there, same in Little Chute, and now we get to us right here in Kaukauna. So where we've got the mills by us, and look at all this that ended up with us here. Before we get to the dam in Wrightstown, then it stops for a while until we get up to Little Rapids Dam, and then after that up to De Pere, and then into the Bay of Green Bay. There was a lot. So I know we just watched the video, so you saw some of these. So here's one of those boats that was dredging the bottom of the river. Another one right here. It's literally got that impeller on there where it sucks up the bottom of the river, puts it in here, and so there's the impeller right there. That's what sucked up all the dirt and the water at the same time. Then they put that all into these giant bags, and they let that sit, and they just pull it out of the river, and now it's just sitting on land. If you used to drive through Green Bay over any of the bridges over the bay, you'd be able to see these. They just had giant stacks and giant like spots that just had a bunch of these bags there. Here's more, and you can see how big they are. Like this, these are adults, grown adults, who are standing next to these giant bags. There's another pump system. Just more views of the bags. Here's that separator that they had shown us in the video. Is that bad, gross sludge. Here they are putting it on those trucks, and you see they've got the tarps on there because remember how inhaling it is bad, especially ones that, like, now this is really concentrated PCBs. They don't throw those tarps on the top and just kind of let it drive away. That would be terrible. They pull this across the top too after they tarp it as well, and then they dump it. Now, what do we know? I'm going to go back to that. What do we know about dumps? We know that that's not a great way to dispose of waste, but here it is. So that may be something that comes up in the next few years, or maybe it's forgotten about until 50 years down the road or something. Just like, hey, remember all that toxic chemicals we put in a dump? We'll see what happens when we get there. Here's just where that all used to be, and these are plaques that say, like, this is the great PCB cleanup. This is what happened. This is what happened. So kind of what I've been talking about. So why do we even talk about the PCBs? This goes back to the bioaccumulation we've been talking about the last couple days. So bioaccumulation is that normal and essential process for the growth and nurturing of organisms. Like I said, it's not always a bad thing, bioaccumulation. So all animals, including humans, bioaccumulate our vital nutrients. Protein, fat, carbs, vitamins, minerals. Bioaccumulation is necessary, but it also can lead to the accumulation of bad things, which is why we're talking about PCBs. So we have organismal bioaccumulation, where the organism just eats it themselves. Trophic transfer. Trophic meaning trophic level, meaning the level in the food chain. So here's trophic level 1, 2, 3, 4, 5. Actually, sorry, water isn't a level. So 1, 2, 3, 4. And then soil bioaccumulation. So it just ends up in the soil with the other organic material that's down there. And actually, I'm going to go back here. So this is bioaccumulation. But remember biomagnification? See how we start with 0.04 parts per million of whatever chemical was in the water. Now we have 0.5. So you multiply that by 10 and then even a little more. Then we go up to 2. So we have 0.5 going up a lot. And then we have 2 going up to 25 parts per million. So that biomagnification is just making it orders of magnitude. So meaning like 10 times more at least as you're going up there. So here's just a couple ways to show the bioaccumulation process. Uptake is that process of passing the chemicals from the environment into the cells. So it starts out in the environment, gets into the small things, then the bigger, then the bigger, then the biggest. Now this is a picture actually from Michigan, but it does show us exactly what I'm talking about. Many ways chemicals end up in lakes and rivers. Here's PCBs right here, little blue dots. And then they just sink to the bottom where they settle in that sediment. And then small creatures called macroinvertebrates eat these chemicals as they dig in the sediment for food. So things like are literally eating dirt pretty much to get the nutrients out of it. And then small things will eat those. There's a PCB right there. And then a bigger thing will eat them. There's a bunch of PCBs in that. And now a bunch of PCBs. You can see this big fish has a small fish and a smaller with macroinvertebrates in it. So all of this is, they're getting more chemicals as they go up. So the macroinvertebrates are eaten by the minnows, then are eaten by the medium-sized fish. Those fish are eaten by large fish, and they keep eating those chemicals because they're eating the things that ate the chemicals. So that's why larger fish, longer living fish are likely to have more chemicals in them. This is a picture from Michigan, like I said, so it says Michigan Fish Advisory. But if you go down to Thousand Islands, you see those signs that say, "Don't eat this fish ever," or "Only eat one of these fish a month," or something like that. I forget what the signs say now. It's been a bit since I've been down by the river, but this is why. This is why they tell you not to eat all those fish. Just another way to show it. So say here's the Fox River. Now we go from the Fox River, say, to the Great Lakes, and the Great Lakes to the rivers leading out to the ocean. So now we've got that stuff coming out to the seawater. And then it gets into the ground, underwater, and it gets into the plankton, and it gets into invertebrates, fish, birds, mammals. That's, again, why they had to treat bottlenose dolphins and killer whales as toxic waste, because they have all of this stuff in them. Some factors affecting bioaccumulation. So the time between uptake and eventual elimination. So if they're in for a very long time, the duration of exposure. If, say, a fish lived right in one of those really sedimenty areas right before the dam for a long time and then moved after the dam, so they wouldn't have as much in them afterwards. And then just their behaviors. So, do they spend a lot of time rooting around in the dirt and stuff like that? And here's just another showing that, the big walleye's the biggest thing, plankton the smallest thing, how fast this goes up. And remember what kind of growth this is? This is exponential growth. Now, I will be posting these questions as well. This is what your assignment for today is going to be. You need to answer me these questions. So what percentage of the total PCBs used by the paper industry in the Fox River were dumped into the river? What's one type of fish that can be purchased at a restaurant or grocery store around here that we should be aware of? Which part of the fish has the PCBs in it? Give me one specific reason why they're a dangerous toxin. Name the industries that currently manufacture and use PCBs. What industries are responsible for dumping them in the Fox River? And then how could they be removed from fish prior to cooking and eating? Some of these you may have to do a quick Google for, but a lot of them were answered, most of them, I think all but one, were answered in the video or this. There we go. That's today.